My name is Gabrielle Hercht, and I am a historian at the University of Michigan, where I also direct the program in Science, Technology, and Society. I have spent my whole career working on the history of nuclear things. I began when I was a graduate student with a dissertation on the history of the French nuclear power program. The early decades of the French nuclear power program, where I was particularly interested in questions related to the relationship between technology and politics and how these played out in choices about reactor design that really were also choices about the future direction of French security, of national identity, and of the ways in which French society reconstituted itself after World War II. And then after that, I became very interested in the colonial and post-colonial dimensions of the nuclear age. And I set out to rethink the history of the nuclear age from this perspective of colonies and areas of the world that had provided either testing grounds or uranium to nuclear power systems and nuclear weapons, but that had been written about very little. And in the end, I focused on the history of uranium production, primarily in Africa. The book that I published recently, first in the US and then just last week in France, is about the production of uranium in Gabon, in Madagascar, in South Africa, in Namibia, and a little bit in Niger. And it asks two questions. One is, how does uranium become a market object? Because uranium is not the kind of product at the beginning, immediately after World War II, a lot of effort was expended by the United States and Britain and France to be sure that uranium would not be a market object. So it was a material that needed to be controlled, that was only subject to government oversight. And the United States in particular did a lot to put in place a variety of structures that would make it impossible to marketize or monetize uranium. And then in the late 1960s, early 1970s, with the development of civilian nuclear power, the opposite sorts of efforts were engaged in order to, what I argue, denuclearize uranium. Say that turn uranium into a non-nuclear object so that it could be monetized, so that it could become a commodity. And doing so involved the very active exclusion of these newly independent states and their leaders, such as Gabon or Madagascar, from the global production system of uranium. So part of the book looks at that. And then the other part of the book looks at what happens in the uranium mines themselves. So what is the process of mining the uranium like? And what does it mean that in many of these places and at different times, uranium mining was not considered to be a nuclear activity? So the only reason that people were mining uranium, trying to extract uranium, was to provide fuel for civilian nuclear power plants or for atomic weapons, or very often both. But the activity of producing the uranium itself was excluded from regulatory mechanisms and knowledge production mechanisms that made certain kinds of activities and things nuclear and other things non-nuclear. And the result of that, of course, is that a tremendous amount was not regulated. So uranium mining was not regulated as though it were nuclear work. It was regulated as though it were ordinary mining, which meant that radiation exposures were not measured, various things like that. But this was uneven. It was different in different parts of the world. So, for example, in France, because uranium was mined in France as well, uranium mining was regulated as a nuclear activity by the French Atomic Energy Commission, the Commissariat à l'énergie atomique. And there were a whole series of experts within the CEA who studied the effects of uranium mining on health, or most especially who worked to regulate the levels of radon and other radiation in the mines. But these same institutions, when they went to Gabon or Madagascar, had neither the personnel nor the will to treat uranium mining in those places as fully nuclear activities. So the same kind of action on the part of the workers would be regulated differently, and the workers would have a different experience there. So the book overall kind of examines the political and health and environmental consequences of labeling certain kinds of activities as nuclear and other kinds of activities as non-nuclear, and argues that there is that nuclearity is not a given, does not derive automatically from the presence of radiation or fission, that it's something that needs to be constructed through technological practices, political practices, regulatory practices, cultural practices. Nuclear power in France, the nuclear power program in France began immediately after World War II. Was led by Frédéric Joliot-Curie, who had a nuclear physicist and chemist who had been studying fission and other aspects of nuclear science for some time, and very much had the backing of the immediate post-war government. And at first the idea was to simply build on the research that French physicists and chemists had engaged in. But very soon, the idea became to develop a full-fledged nuclear program in France. One of the interesting things that is in fact not particularly unusual to France, but the way it played out in France was a little bit unusual, is that at the beginning, in the immediate post-war period, the successive French governments of the Fourth Republic declared time and time again that France would not pursue a nuclear weapon, would not pursue atomic weapons, that France would only pursue peaceful avenues to the atom. Joliot himself had declared this so forcefully that he had actually declared that France would never pursue a nuclear weapon that could be used against the Soviet Union, because he himself was a member of the Communist Party. And that made the Americans very uneasy. And they put a lot of pressure on the French to remove Joliot from power at this point. So, but you still had, for most of the Fourth Republic, you still had both government leaders and scientific leaders declaring that France would not build nuclear weapons. However, behind the scenes, things played out quite differently. There were a number of polytechniciens, of engineers, highly placed engineers in the Commissariat à l'énergie atomique, who thought that France should develop a nuclear weapon, who knew that they had the backing of de Gaulle, even if de Gaulle was not in power at the time for this. And there was this famous meeting in 1954 with Pierre Mendès France and Pierre Guillaume and some of these other leaders, where the engineers kind of presented the situation to Mendès France and presented the prototypes that they had developed for building reactors at Marcoule that they said were supposed to be for civilian purposes, and pointed out that these same reactors could be used to manufacture weapons-grade plutonium, depending on how you optimize the reactor. So really the same design could be optimized in a few different ways. One would be to produce energy in an optimal fashion, using up the fuel as much as possible, and the other would be to operate the reactor in such a way that rather than using up all the fuel to make electricity, there would be weapons-grade plutonium left in the reactor core. And so the decision was made to leave it ambiguous in the end, so that in the end, the declaration was that France would never pursue an atomic weapon, but the fact was that these reactors were in fact producing weapons-grade plutonium. And as it turns out, these prototypes of the reactors at Marcoule were the basis for the design of EDF's first generation of reactors, some of which also produced weapons-grade plutonium for the French nuclear weapons program. So I call this process a technopolitical process, where it's not that there is a technological design that is that exists apart from the political imperatives, or that there is a political decision that exists apart from the technological capacity to pursue that decision. We see in this kind of situation that really the two were developed together, so that when de Gaulle came to power and the Fifth Republic was declared, it was only a matter of months, really, before France exploded its first atomic weapon in the Algerian desert at Regan. Now, the first generation of French nuclear power reactors, in a way, retained some of this ambiguity. And there's a lot to say about what happened later. Eventually, the French abandoned this gas graphite design in favor of a license that EDF purchased from Westinghouse for pressurized water reactors. And the big nuclear buildup that people typically think of when they think of the French nuclear power program was under the auspices of that pressurized water reactor license that was purchased from this U.S. company, Westinghouse, and then Frenchified, in a sense, francisé, and a lot was made of that Frenchification. But the other part of what I argue in the book is that in the process of building these technologies and of operating them, because I also spend quite a bit of time looking at the different labor regimes in the French Atomic Energy Commission and in Électricité de France, which had quite different ideologies about what the relationship was of labor to the nation. And those ideologies played out in the way the nuclear power plants were operated and in labor relations within the plants themselves. So many of the kind of, even though the design was different, many of the techno-political patterns that were laid down in the 1950s, I mean in the, well, 1950s, but especially the 1960s and the 1970s, were translated into some of these other designs and these other reactors that were operated in the, built in the 1970s and really began operating full force in the 1980s. And over the course of this time, I mean, I also have looked at particular regions, especially the region, the department of the Gare, right around the Marcoule region, and the Indre-et-Loire, right around the Chinon reactor, and kind of examined the tensions between the discourse that was emitted by promoters of the nuclear power program and that was reproduced by journalists. So comparisons like the Marcoule reactor is compared to the Cathedral of Notre Dame, or to the the amount of metal that's used in the reactors compared to the amount of metal in the Eiffel Tower. These big symbols, almost cliched symbols of French nationalism. In the Loire, the reactors at Chinon were compared to Les Châteaux de la Loire, and I even was given one of the reactors that I went to, the Saint-Laurent-des-Eaux, they gave me as a little parting gift a medal that had engraved in the foreground the outline of the Saint-Laurent reactors, and in the back the outline of the Château de Chenonceau. So that these kinds of associations were built into the nuclear program and made concrete in a whole variety of ways, technological, political, cultural, social. So that when you speak of the nuclearization of France, what you're really talking about is not just the building of these reactors that, of course, eventually produced today between 75% and 80% of French electricity, depending on the year. But you're also talking about the building of a set of associations, cultural associations, cultural images, daily practices that reinforce that kind of performance, the performance of a certain kind of French nuclearity. Which is not at all to say that it's hegemonic. There have been, particularly starting in the 1970s, but even in the 1950s and 1960s, movements that tried to break those associations and to say, no, this is not the France that we want. We don't want a nuclear France. And in some cases, we don't want a nuclear-armed France. In other cases, we don't want a nuclear-powered France. So that tension between whether the French nation should be a nuclear nation or not, that tension in French society, I think, has also existed. And I think one of the problems with how a lot of outsiders see French nuclear development is that they only see the success part, or they only see the spread of French nuclear power. And I often get asked about why is there no opposition in France? But of course, there has always been opposition in France. So that's part one of your question, is how did France become nuclear, you know, through a whole variety of these kinds of performances. All countries like to aim for energy independence. That's a major political goal that really developed in the 20th century. And France, of course, is no exception to this. In France, initially, energy independence had a lot to do about anxiety about oil production. And certainly when Mesmer promoted, starting in 1974, le tout nucléaire, all nuclear, all electric, the context of this was the oil crisis and the idea that, well, en France, on n'a pas de pétrole, mais on a des idées, and those ideas, that in France we don't have oil, but we have ideas, and those ideas were nuclear ideas, and nuclear power plants. Now, the idea that nuclear power plants would give France energy independence is based on the idea that the only thing that counts for energy production in a nuclear system are the power plants themselves, right, which are designed or redesigned, I should say, in France, built in France, they operate in France. But of course, these power plants, particularly starting in the 1970s, were not powered by material that was physically found in France, or only a very small amount of the material that powered the plants was found in France. Much of it came from uranium mines outside of France. And in fact, much of it came from uranium mines in Gabon, and especially in Niger, where the French rapidly developed some of the largest open-cast uranium mines in the world. So that the claim of energy independence depends really on two moves. One move is to cast uranium mining as a non-nuclear activity, so that it is peripheral to the central activity, which is producing the electricity on French soil. And by casting uranium mining, especially uranium mining on the African continent, as a non-nuclear activity, that makes it possible to sideline the fact that so much of the uranium that necessarily powers the reactors comes from a different place. That move also depends on what a number of activists have come to call the France-Afrique, this merging of France and Africa, this preservation of Francophone Africa as a précaré, a kind of special hunting ground for France, in which to get, of course, not just uranium, but oil as well. And to say that there is a sense in which, even though colonialism is over, the special relationship between France and some of these African nations continues. Some of this continuation is through a series of secret deals, but some of it is just through business, and through the preservation of business relations and political relations between France and Gabon, between France and Niger, and of course other countries as well. So that there's this kind of double move, which is why it makes sense to think about it technopolitically, where the claim to energy independence relies on both of these kinds of things in order to make it work. And I want to stress that it's not that France is unique in this respect. You know, other countries do the very same thing. The United States also makes these insane claims to energy independence. Many countries do this because this has become the kind of the big geopolitical goal that they are trying to sell to their citizens. But what's interesting in the devil is always in the details, and what's interesting in the French case is the ways in which those claims operate on French soil, but then also operate on African soils. Well, you know, there's no question that nuclear power produces less carbon dioxide than coal or oil-fired power plants. It's important not to exaggerate the claim. That is to say that that those who say that nuclear power is zero carbon, you know, that's a wild exaggeration. There's a tremendous amount of carbon that gets expended in mining uranium, for example. And there's a lot that doesn't, the other big part of the cycle that doesn't get taken into account is the waste part of the cycle. And in fact, I shouldn't even be calling it a cycle. A cycle is is actually calling it a cycle is a particular kind of political claim that has become so much part of our vocabulary that it, you know, comes out of my mouth, for example, even when I know perfectly well that it is not a cycle, but really a chain is a much better metaphor than a cycle. So the first thing to say about that is, as I said, that it is not that nuclear is zero carbon. The other thing to say about that is that, important as I think the climate change debate is, and I do think it's critical, it becomes a problem when one lets it, when you engage in carbon reductionism, when the claim then becomes the only thing that we should ever think about is how much carbon we're pumping into the atmosphere. I think that there are many other complex aspects to thinking about what it means to produce energy and what it might mean to conserve energy, and that privileging carbon to the exclusion of the production or the risk of other kinds of toxicities, I think will just lead the world down a path that will ultimately have many other kinds of problems associated with it that are perhaps more immediately poisonous to certain kinds of environments. Well, so that's the thing about the waste produced by uranium mining is interesting because it very often doesn't count as nuclear waste. That is to say, it doesn't count as the waste that one would put away in the big waste repositories that are either being built, such as in Finland, or imagined, such as in France. And yet, the waste from uranium mining has spread over much greater distances and contaminated many more people than the waste products of the nuclear power cycle itself. I mean, of nuclear power production. There I go again. Of nuclear power reactors themselves. 10,000 tons of uranium for the British and American atomic weapons program came from piles of gold mining waste in South Africa. So in South Africa, uranium and gold are found in the same ore matrix. South Africa was the world's biggest gold producer for many decades, after gold was discovered in 1886 there. And leading up to World War II, gold was the mineral that was extracted from these mines that were extremely deep mines. After World War II, scientists, engineers, and others realized that these gigantic piles of gold mining waste that were scattered throughout the region around Johannesburg had a very high uranium content. So these piles were reprocessed to extract the uranium, and then more uranium was mined in South Africa, or more ore was mined in South Africa, and both gold and uranium were extracted. Now, of course, what gets extracted depends on what it is profitable to extract. So there is a limit to how much gold or uranium will be extracted at any one time, because at a certain point it becomes too expensive to extract every last little bit of it. So this remining of the waste piles produced more waste, which also piled up in different piles, but also around the Johannesburg region. And if you go to this region, which is now called Gauteng in South Africa, you will still find these piles of waste around, and many of them still contain sufficient uranium to have quite significant levels of radioactivity and emit radon. So you have two things happening here in the fact that these piles of waste were not ever treated as dangerous radioactive waste, right? So they're just left there to the open air. And this has two kinds of consequences. One is that the ones that really are just in the open air, when the wind blows in the winter, which in South Africa it's July and August, dust blows over communities, and of course it's not the rich communities that are in the line of the wind. So you have poor communities where for months their houses, everything is blanketed in this radioactive dust, which they absorb, they eat, it's everywhere. The other thing you have in these particular mines in South Africa is that these mines, as I said, went very, very deep. They went below the water table. So in order to be able to mine them, the mining companies had to extract the water during the mining process. But once the companies find that a mine is no longer profitable, they're not going to extract the water anymore. There's no reason to. They have no reason to. And in fact, many of them abandon the mines. So then the mines over time fill back up. The water table comes back up. But this time, the galleries are exposed. And so the water reacts with the exposed pyrite in the rock, which makes the water acidic. And then that acid water heavy metals are more soluble in the acid water. So you have what's called acid mine drainage that is polluting the water table all over the Gauteng region, where you have acidic water with a pH as low as 2, keeping in mind that neutral is 7, that is full of heavy metals, and that again is contaminating the water supply of the very poorest people in this region. The relationship here to nuclearity is that you have here a situation where, of course, it's not just radioactive contamination that's an issue here. It's all kinds of contamination that mix together. But the fact that despite a lot of scientific knowledge, and this is a dynamic that you see over and over again, of course, in the Anthropocene, despite a lot of scientific knowledge about the toxicity, the radiotoxicity of all of these processes, this material is left as waste to the open air, to the elements, not treated in any special way, and ends up producing widespread contamination, for tens of thousands of people at a minimum, that there's no monitoring, there's no treatment, and at present, neither the South African national government nor the regional government of Gauteng, nor municipal governments in Johannesburg and Soweto, none of these institutions has or is willing to put the financing in that would be required to radically redo infrastructures in such a way as to prevent this contamination. So I use the example of South Africa here because it's so telling, but you find this similar dynamic in other places, including in places where France mined uranium. So activists, for example, have gone onto the open market of Arlit, which is the town that French mining companies built to support the 2 big uranium mines in Niger, and they regularly find radioactive scrap metal for sale on the open market here that people are thrifty. They reuse products, particularly in poor settings. They're not, they don't just go and buy new things all the time the way you might in Europe or in North America or Japan. They reuse the materials, and in a situation, in a place like Arlit, the materials that they're reusing, very valuable metal from one perspective, is also contaminated scrap metal from another perspective. So that again, the dismissal of these objects as nuclear waste, leads to a kind of contamination that never gets measured, doesn't get taken into account in any of the formal sciences and engineerings disciplines that address nuclear waste from the perspective of that produced by reactors or that produced by atomic weapons manufacturing. And I'm not necessarily saying that the same institutions should be, there isn't place in these nuclear waste repositories for mining waste, and I'm certainly not saying that, rocks from Gabon should be shipped to Finland or should be shipped to Eastern France for burial, but we need a much wider set of practices and imaginations for dealing with the very wide range of radioactive waste that this one industry inevitably produces. radioactivity really is something that has, the experience and imaginaries of it have changed considerably over time. You know, in the early 20th century, a lot of the attitude towards radioactivity was this kind of marvelous thing. You know, it allowed you to see through skin, and, you know, you could see, you know, this is where X-rays come from, of course. It was this magnificent scientific tool. And so most of the experiences, most of the discourse that you would see about radioactivity before World War II would be positive discourse. Very rarely you would see a discussion of the dangers of radioactivity, but I won't elaborate on that. You would see it a little bit, but not very much. The dropping of atomic bombs on Hiroshima and Nagasaki is often constructed as this rupture in our consciousness. And one can debate whether it's really a rupture or not, but the reason that it gets constructed as a rupture is precisely because of radioactivity, in a sense, right? That you have this substance, or it's not really a substance, it's really a process of ionizing radiation, where you have elements such as uranium and plutonium that decay, and in the process of decaying liberate particles, various particles. There are different kinds of radioactivity that in turn get absorbed by living things, and sometimes, and in some occasions, change cellular structures. Depending on what kind of radiation you absorb, and how much of it you absorb, and over how much time you absorb it, but also depending on your makeup as an organism, whether you be a human or a non-human, that exposure to radioactivity can lead to a variety of different kinds of illnesses, including cancers, including genetic mutations. And it was that genetic mutation that really captured the imagination immediately after World War II. So that in the North American press and in the European press and in movies, you would see these, you know, things like Godzilla, for example, that everyone knows. That, you know, supposedly in Japanese film was a product of exposure to radiation. There was this film in the United States called Them that imagined these gigantic ants who had been exposed to radiation and were then taking over the world. A lot of comics, of graphic novels with superheroes, with superheroes, also imagined these heroes as having somehow been transformed, sometimes for good, sometimes for evil, by radiation. Now, of course, those are big, explosive imaginaries, and today, the nuclear industry often laments these kinds of images because they say that it has produced in people radiophobia. So when leaders in the nuclear industry talk about accidents at Chernobyl or Fukushima, they say, look, people haven't died from exposure to radiation. There have been very few deaths. Chernobyl, only 4,000. Fukushima, you know, just a handful of thyroid cancers in children that really have not even fully been linked to radiation exposure. And that really what people have is a lot of fear of radiation. And that we shouldn't be worrying about this because there are sources of danger and toxicity everywhere in the world. But, you know, as you suggested, part of the problem, of course, is that radiation is not something that can be experienced sensually by the senses that we have access to as human beings, bipeds walking around in the world. And that it is true that there are so many forms, so that I'm sitting here outside, of course I'm being exposed to radiation from the sun. If I go up in a plane, I will be exposed to more radiation. Bananas have a small amount of radiation in them, so some humor-filled person started talking about the banana equivalent dose. How many bananas would you have to eat in order to be exposed? So there's sort of all different kinds of ways in which different parts of the spectrum of attitudes towards nuclear things have tried to talk about what it means to understand radiation. To use a phrase that is being used here in this seminar, this technosphere seminar, the question is, how do we sense the insensible? What kinds of instrumentation, what sorts of sensory experiences are accessible to us in order to make sense of something that we can't see, we can't touch, we can't smell, etc. And all we have for radiation is instrumentation, and the instrumentation itself is extremely limited. So the same dosimeter that will detect one form of radiation, gamma rays, is not able to detect another form of radiation, alpha radiation. Gamma rays is what people think of when they think of Hiroshima and Nagasaki and melting skin and all of those things. Alpha particles are what people inhale when they inhale radon, which is a gas that is produced by the decay of uranium. Radon is very often present in underground uranium mines, so uranium miners are particularly susceptible to inhaling radon. But radon is also present in the bedrock, so that there are many houses that are far from uranium mines per se, but that are built on bedrock that contains uranium and that have high levels of radon in their basement. So for example, in the Limousin in France, you'll find very high levels of radon in houses in the Limousin because it is precisely such a rock formation. So the complication is that in order to detect these various forms of potentially very harmful radiation, you need instrumentation. You need instrumentation that is designed to function under very precise conditions, so that measuring radon in your basement is not something that you can just stick a measuring device down there and then assume that it's going to tell you what you need, because the conditions are continually fluctuating and the instrument needs a particular set of conditions in order to function properly. So this is not a kind of thing that you can easily construct a network of detectors in order to detect. So for me, I mean, this is a problem that is, I don't have a ready solution to propose to you for this, except that it is important to continue to try to think about the different ways in which we can make these forms of toxicity visible, as it were, or sensible in the sense of being able to sense them. As I'm sure your listeners and viewers know, the question of when and how you date the Anthropocene is, on the one hand, for the International Commission on Stratigraphy, is a geological question, but because the Anthropocene has gotten such political traction, it has in fact become a political question across disciplines and throughout. So that I think there are two problems with using radioisotopes and radioisotope signals as a date for the Anthropocene. One is the insistence that by doing so, it is possible to capture something that is globally homogeneous. And while fallout from atmospheric testing is did spread out over the globe, we don't actually know that it's globally homogeneous because we don't have fallout stations in many places where we might be able to detect plutonium-239. And also because the experience of the nuclear age, as I've suggested earlier in this conversation, is not at all globally homogeneous. So there is a problem with using that in this particular way, perhaps not a geological problem, but a bigger political problem with using it in this way, because it suggests that there is, in fact, a single kind of way in which humans have lived in the nuclear age, when there are, in fact, many ways in which humans have lived in the nuclear age. Another problem is that the Anthropocene, it suggests that the Anthropocene is just about nuclear things, or is reducible, perhaps that is a better way to say it, reducible in terms of and analysis and you know, to nuclear things. And I know that they say, well, you know, this is good because it also, the timing corresponds with the emergence of plastics and, you know, other anthropocenic kinds of markers. But I would venture to say that advocacy of a single way of doing things, a single way of knowing, a single best way, is what landed us in the Anthropocene to begin with. So that if we then pursue that singularity in the ways that we try to apprehend the Anthropocene, we run the danger of perpetuating the same problem in terms of our knowledge production. There's been another paper that suggests, kind of in response to Zalazevich, that yes, you know, radioisotopic markers are important dating techniques, but that different markers tell you different things and suggest different kinds of dates. So that if you were to use lead isotopes, that would lead you to start the Anthropocene in Roman times, when lead became a widespread use in materials. So that, you know, if you're going to advocate radioisotopes as a means for dating the Anthropocene, then you are presented with a much bigger choice of which elements to use than simply advocating one radioisotope, plutonium-239, as the marker. And in a way, I think I like that paper very much because it offers us a way, you know, both to say something useful to geologists and others who are looking for particular forms of knowledge production, but it also reflects the complexity of differential human activity in different parts of the world, which I think is a complexity that needs to be reflected in the way that we understand and produce knowledge about the Anthropocene. You know, historians always balk at the questions about the future, right? We're supposed to be a retrospective discipline and not a prospective one. I think we have many futures in front of us, and some of them may lead to hope. I mean, we are sitting in Germany, in Berlin. The German government did decide that it was going to try to develop other forms of energy other than nuclear energy. That's the kind of future that gives us hope. At the same time, we have nuclear reactors that are being built in China in a record time of 5 years. So, you know, whereas it might take 10 or 15 years, which is its own kind of problem, in Europe to build a nuclear power plant, the Chinese are putting them up in 5 years, you know, citing this as a gigantic success story. In South Africa, Jacob Zuma, the president of South Africa, is currently in deep political trouble for a variety of reasons, but one of them is conflict over his plan to team up with Rosatom, the Russian, you can see I'm a child of the Cold War, the Russian nuclear power builder, to build 9 nuclear reactors in South Africa. I seriously doubt that will come to be. I hope it will not come to pass because it is a bad idea on so many levels. But that the seduction, the apparent seduction of getting a lot of energy from a tiny rock has proved over and over again to be a powerful lure for governments and large corporations. So that, you know, on the one hand, you have activists in Europe proclaiming that no, nuclear power is on the wane. That might be true in Europe, but it's not true elsewhere in the world. And the one thing that accidents like Chernobyl and Fukushima tell us is that the effects of those accidents, when things go wrong, doesn't necessarily travel all over the world in a homogeneous pattern, but it does absolutely cross national borders and goes down into oceans and, you know, affects many forms of life on the planet that are, you know, far from the center where the problem was produced. And I see that problem getting worse in my lifetime and not better. I'm a pessimist.